Hey folks, I just got the core stand up. I think we'll get some folks here soon. We were just talking about, it sounds like maybe we've got the build issue fixed this morning. So not performance related exactly, but good news. Um, the long saga of that is we were running on like Gluster for a while just because it was like what was set up years upon years upon years ago. And we moved over to I think it was in the process of moving it over to Ceph, we ended up with a Ceph related problem that I think we've got fixed now. So uh, yes, Casey, I see the hands of joy. It sounds like Radek was saying that he submitted something this morning, and it went through and built on CentOS 8, which was the issue that we've been having. So anyway, lots of good stuff. All right. Oh, I see, Josh, you're adding a bunch of stuff here. Very good. Very good. Um, Before we get into all that, I'll quickly go through pull requests, and I almost made it through the list. I got really close. Okay, let's see. New this week. Igor, you've got this very interesting looking bounded iterators for ARM range keys.
Yeah, indeed.
Anything? Well, I saw you added Corey as a reviewer for it. So Corey, so you know, you've been tagged. Um, anything interesting there, Igor, to watch out for with this?
Well, first of all, I managed to reproduce that locally. So, I mean, to reproduce the issue locally with RocksDB performance declaration. And it was OMAP clear function, which called RAM range keys and iterated over multiple column families and column family shards, and it counted up to 1 million keys to check if it needs range delete or not. And this definitely triggered the issue. So once I implemented this bounded stuff, it gone away. Well, I'm still checking the more advanced approach, which is apply range deletes unconditionally. And honestly, I don't see any issues so far. Yeah. Not to mention that generally it looks like a design flow that if we stuck at some function doing something for a long time, some function at BlueStore, we effectively stall the current thread, then another thread from the same OSD shard, and potentially if if we have multiple clients which access PG randomly, we can cause them to stall completely. So, well, I mean that single misbehaving thread might effectively stall the whole BlueStore. Not sure I know the way how to avoid this, just to share.
Igor, I had a test case that did really, really badly when we had completely unlimited range delete before. It was an RGW test case. I was just looking for the PR where I had the stuff there for it. Hmm, I have this. Well, in any event, I can find it again. But if it's useful for you, we could try running through those old test cases again and see how it does if we allowed for range delete to happen with fewer elements.
Yeah, definitely it would be great to be able to reproduce the tissue and try it against this.
Yeah, it's pretty old. I thought it was like from 2017. I'm trying to find it again.
Uh,
Oh,
well, I have one thought that maybe the analysis, the root cause analysis wasn't 100% valid in that time. So could it be that something like this unbounded uh, iterators could trigger the actual issue, not the range deletes? Because, I don't really understand what's the big difference between single key delete or ranged one in terms of uh, handling afterwards.
yeah, I mean, the impression that I got from comments was that the range delete tombstone is different than a normal deletion tombstone. But I don't know in what way it's different. I never was able to really find out, and I never dug through the code enough to really understand it. Um, I can show you though. I found the PR that where I was testing the behavior. I don't know. Maybe this could have been more related to some other aspect of this, but it appeared that for whatever reason we did range delete with a small number of keys that the it made iteration extremely slow in general.
I'll say that I've sort of tested both over time, and I haven't seen really any difference from my side between a delete range tombstone and the same set of individual tombstones covering the same contiguous range. But in either case, if you have a large swath of a contiguous range of tombstones, whether it's from a delete range or individual ones, both of those cause a big problem.
Corey, did you notice any difference if you had, like, say, if you did small delete ranges versus individual ones? So if you had, like, say, um, a delete range only covering a couple of keys versus individual keys, would that show any difference?
I don't believe so because what I've seen the problem as is that right when you do like a lower bound call and that lower bound call is within or at the beginning of a range that is full of delete tombstones or a delete range tombstone, it first has to do a binary search to find the lowest key in that range, right? And then it has to go back and check whether it's deleted, either by looking at individual or range tombstone. If it finds that it is, it has to do that binary search again. And so if you have a million contiguous tombstones like that, it's doing a million binary searches and coming back and looking if it's deleted until it finds something that isn't.
Okay.
And so regardless of whether they're multiple tombstones or not, it ends up doing the same thing.
I wish I could understand why we saw the behavior we did back when this other PR that I did merged, where we basically only used delete range when we had large numbers of keys. I guess I included a little bit of a profile in this, but it's not super useful. Just iteration overhead is all we know, really. In make shared, Huh.
I'm struggling to remember it now, though. I think I did see some notes in RocksDB change logs about there being bugs with delete range in the past and prior versions that may have caused some performance type issues, but I'd have to dig that back up to see what that was. It was,
Yeah. Maybe this isn't valid anymore. Like maybe there were bugs that have been since fixed. Well, in any event, Igor, we can try testing your stuff, testing just in general, and testing your stuff again.
Yeah, well, I mean, this bounded stuff makes sense indeed, and I think it worth backporting as well. And meanwhile, we might want to proceed with uh, using range delete unconditionally in main branch and see if works properly.
Yeah.
Hence, bake it for a while.
All right. Cool. Let's see. Moving on. It looks like this initial commit adding arrow flight functionality has merged. Since we don't have Eric, Casey, was there anything interesting about that or anything new?
Well, there's a lot of interest from our team in Aeroflight and integrations, but we're still trying to find kind of the right model for that. This
Okay.
PR does it in kind of a weird, hacky way that is not going to be the final product, but gives us something that we can point clients out and experiment with.
And remind me what the Aeroflight stuff is again.
Uh, I'm probably not the best person to summarize this, but it's a fast RPC framework for low latency data transfers.
Okay. Okay. This isn't related at all then to the like fast S3 stuff that we were talking about a while back.
Uh, Possibly. The idea
Okay.
for RGW is that we kind of use this as a side channel for clients to request, you know, or query specific parts of objects. I think there's potential for using select like statements through that also.
Cool. All right. Well, yeah, it'll be exciting to hear more from you guys as you try it out and see if it works well.
Yeah, I think there's potential for integrations with OSDs also, so that RGW could like describe the layout of data and have it fetch things directly, but
Oh
that
wow.
definitely needs more elaboration.
Yeah, that'd be exciting. Huh. Well, very
And
cool.
there would be lots of consistency issues with OSD maps, etc. So I'm not sure what exactly we can do there.
Sure. All right. Well, let's see. Next, I think this was just get closed. It was a pretty old PR for rewriting the hardware docs. I suspect that maybe that's been superseded at this point. But it got closed, so I put it in here. Let's see. Updated. Oh, I'm missing part of this one. I don't know who wrote this. Do not collection list when remove collection. Let me look at it quick. Uh, Raython. Okay. Let's see. Uh, Corey, it looks like maybe you were reviewing this one.
yeah, I've looked at it a few times and added some discussion points in there on that one. I think there's probably more discussion warranted on it as far as whether what approach we really want to take long term, I guess, on that piece.
Yeah. Okay. Sounds good.
I just can add that
Empire.
I agree with Igor assessment on this PR that we check if collection is not empty because we have a strict assert for trying to delete non-empty collection on BlueStore. Maybe we could revert it, but for now we need to be wary that this change itself will cause OSDs to potentially just flip.
Okay. Sounds like if people are concerned about it, we should maybe either request changes or maybe reject it so it doesn't just languish. What do you think, guys?
Well, actually, this doesn't make much sense in regular operation, since most of the time we do not see any assertions. But it might be useful for troubleshooting, since it provides early diagnosis for issues like that, like improper collection removal and complete collection removal. So, in this respect, it looks like we might want this stuff during QA and maybe have it optionally enabled in case of some issues in production. From performance point of view, it's better to avoid to get rid of it. I mean, disable it, for instance. Can say that this looks as a elegant approach. I mean, having an option to enable and disable it, but no, I don't know. I don't see any better approach so far.
Igor, maybe just put a comment in with what you just said. Do you think, if you think it's reasonable, if we just have an option for it, maybe that's the way to proceed.
Yeah, well, the question would be if someone needs this option in production. Well, I don't know. Yeah, looks like the option is the approach that might work.
Well, the argument against this PR would be also that we, as far as I remember, check if there are any objects in the collection anyway. So even if we skip trying to list any object on that level, we still do that entire access to RocksDB in BlueStore anyway. Maybe the proper approach would be to improve handling of deletion of non-empty collections.
Well, Adam, I believe this PR works in a different way. So it removes the check from the check for empty collection in at BlueStore level, and we still have it at SD1.
Okay, I might, in that case, disregard, I might have misread the code here.
Yeah, my other thought is that we could potentially keep the one in Blue Store, the one that he's removing in that PR, and return an error code if Blue Store does detect that there are still objects in there during that iteration, and bubble that up through Q transaction so that we can remove the one in the OSD layer and then end up having the same logic for retrying the PG deletion when that is the case, if new objects had been added, instead of doing the assertion failure. That way we still have basically the same failure or the same invariant protection at the Blue Store level, but we avoid doing that expensive iteration twice.
Yeah, this probably can make sense. Um, just not sure if we are able to return code for this specific function. Need to double check since it's performed in a transaction manner. I'm not sure. Are we able to return errors for operations submitted via Q transaction? I don't really remember.
I guess we can. I'm not really sure we do handle those errors very well, but it seems that the path in object store for returning returns for a transaction exists. But handling XOSD code, I don't know that.
Well, definitely OSD code for PG removal doesn't handle that at the moment, but it can be introduced quite easily, I believe.
But now I'm thinking if maybe there is a way that we could store in a Blue Store internal some kind of flag if the collection is empty. Like because the problem here I see is that we do iterate over entire collection in submit transaction, and the delay here is a poison for us. If the same delay happens when we list collection, we will be fine with it. So maybe if we could somehow pass an info that last search through a collection gave us no object, we could use that in remove collection and use that as a gate for immediate deletion.
Yeah, we might apparently introduce some tricks with timestamps and have something like last update timestamp at user level and compare it, or check it during removal, during PD removal at SD level, something like that. So, well, anyway, it looks like we have some ways to improve this PL. So let's discuss something about the approaches offline.
Sounds good. All right. Moving on then. Let's see. Next, Sam reviewed this mclock PR for adding the ability to handle high priority operations. I didn't look super closely at it, but it appeared Sam did a pretty in-depth review, so that looks good. Moving along. Let's see. There's been, I think, a little bit more discussion on Corey's PR for setting RocksDB iterator bounds for Blue Store collection list. Corey, was there anything new there?
No, I think Igor reviewed it and we had a little bit of discussion, but I think he approved, and I added the needs QA label at this point.
Ah,
Make sure it's
fantastic.
Bathinitis.
I'm just going to add that then. All right, good deal. Next, upgrading RocksDB to the latest Facebook release. We discussed this last week. I just put a note in there that we can't actually adopt Facebook's branch. We have to use our own because there's still that fix from several years ago that we still decided we want to have. So I just sent the author a note saying that we still need to do that, and if he could update the PR, that would be fantastic. And then lastly, for updated PRs, there's this adding primary balance scores. Let's see, Laura, are you here today? I don't see Laura. She just added a slight suggestion to part of that code.
I'm here.
Oh, okay, good. Hey, Josh. Yep.
Okay. There is a slight problem with the score calculation, which is it's very easy to define the score when primary affinity on all the OSDs is 1. But when it's a more conceptual problem to have how to actually define the score when every OSD has different primary affinity, to have something that is meaningful, the number that the user could interpret in a normal way. And so I added a unit test that run random tests and that I could run them. My goal was that I would have when in all kind of corner cases when the score doesn't make a lot of sense. For example, if we have replica 3 and all the OSDs have primary affinity of 0.2 or something, you can't actually meet all the requirements without you're breaking the rules of the game, because you give more primaries than what the primary affinity asks you to do. Obviously, it is possible if the total primary affinity is too low. So I try to do something that in all these corner cases I give 0, and in all other cases score is always larger than 1 and has meaningful something that you could look at the numbers and understand something out of this. I'm still struggling with this actually, so I could easily explain the score when the total primary affinity is high, and it tends to be more and more, let's call it abstract number, when the total primary affinity of all those is becoming low and reaching near the one divided by replica count. So now I think about a bit of different approach of setting the score again when I have a low primary affinity. I'm working on this, but I still need to. Worst case scenario is that in some cases the score would be smaller than 1, and there will be documentation explaining that this is something that says something is bad. But I probably I would be able to fix it, and the only making the score always larger than 1 is simple. The complex is making it meaningful, so that you could look at it and understand something out of it. How much your system is balanced or not balanced. The goal is that 1 is perfect. 1.1 means 10% degradation in read performance. 1.2 meant 20% degradation. That's the goal. I'm working on this because it's tricky when the primary affinity numbers are random. They shouldn't be, because they should have some logic behind them, but I don't want to count on exactly how systems are set in the field and say that this is the illegal configuration. Well, if it's accepted by Ceph, it should be handled correctly. So currently there are minor tweaks to the numbers and to the unit test, making sure that make sure that actually I'm able to run it. Currently I have something like I failure in unit test 1 in 500 runs. I want to make it never fail. So I'm working on it. It's still that's the case. But Laura is working on, in parallel to this, on the closing the loop, which is actually creating a read balancer that will work from OSD map tool as the offline capacity balancer works. So it would spit file with commands to actually balance the primaries. That's for the first release. So it should be ready before the feature freeze of Reef. So it's almost there.
Very cool. Well, good luck. Sounds like you've got your work cut out for you. But
I thought that I had the formulas set very well and the mathematics were good, but it was incorrect. I'm still struggling with the edge cases of the math over there.
anytime you do things like this, I feel like it's at least for me, it takes like 5 tries before I can find something that works right. So I sympathize.
I hope I'm in the 4th one.
Yeah. All right. Well, good luck. Good luck. All right. Let's see. I think that's all I had for pull requests this week, guys. Was there anything I missed from anyone? All right. If not, then moving on. Josh, right before I see you've got a lot, so I want to sneak something in quick before I let you go.
Yeah, for sure.
So Adam has been working on all of this work for making snapshots and RBD mirror much faster, and his results are amazing. I've linked the spreadsheet there for anyone that wants to take a look. But the gist of it is that this new code is really, really good, and probably I would say maybe obsoletes the need for my object defragmentation branch that I had worked on, because it's so fast that I think it doesn't even need it. Adam, is there anything you want to talk about with your work, other than the fact that it's amazing?
Well, it's the code itself is not fast. It's actually quite slow, but the modification is that during a cloning of object, making a duplicate, in fact, there is an aggressive procedure that tries to avoid creation of any extra blobs. It tries very hard to keep the count of blobs minimum. So when faced with the problem with constant snap trimming and creation of new snapshots, we do not increase amount of blobs in object store. That's the speed up. It's completely unrelated, Mark, to your work on copying objects from place to place, because data of objects will still be fragmented. It's just the metadata that's in more orderly or minimal state, and that's it. So, and any performance that comes is not from the actual cloning process, which is now significantly slower, but all the other operations we perform in future, including future clonings, of course.
Yeah, Adam, the reason I said it the way I did is because I think with your new code, it appears that essentially the only benefit from my version now is the fact that you're getting defragmentation. I don't think my code will in any way help improve CPU usage at this point, after your work is applied.
Yeah, that's possible.
Not to say that we still might want to defragment objects on clone just to at some point reduce the amount of fragmentation that exists. But I think with your latest code, assuming there are no problems and that it works in production the way it does now, it's looking really, really good.
Thanks.
Yep. All right, so that was all I wanted to bring up with that work. Exciting stuff. So Josh, I'm going to turn it over to you. Looks like you've got really good updates for us here.
Yeah, well, I guess we'll see whether the quality actually is that great. But I did want to give an update since I brought up these issues. I feel like it was 2 months ago now or something like that with the break in between. So just a reminder that there's two things that we saw in Pacific once we were upgrading between Nautilus and Pacific that were puzzling. And this is mostly in the RBD side. We don't have a lot of data points yet for our RGW workloads. The first one is the write amplification issue. Not a lot to say here. We haven't been putting a lot of focus on it. I did, for your thoughts, Mark, I did quickly look at some block trace myself. And nothing was obvious. There was nothing that stood out as like what was an extra write and what wasn't. I think it'd take a lot more picking apart of what. Yeah, exactly. It's kind of hard to match up what with what. What I started to do in Prometheus was we have the Ceph reported how many writes our client's doing. And then, of course, we have the disk write stats from every single one of the nodes. And so what I computed was how many disk writes are happening on average for every single client write that comes from Ceph. And it's pretty clear across the upgrade threshold that it jumps from, it depends on the cluster, it jumps from 2 to 3 OSD writes per client write up to 3 to 4 per OSD. So we're 3x replicated. So this is jumping from 6 to 9 up to 9 to 12, essentially writes across the cluster for every client write. So like it was pretty clear that basically it looks like for some number of volumes, there is one extra write that is happening for every client write that comes into the cluster. That's really as far as we've got. I don't know. I think we had a lot of questions in our minds about like, did object map implementation change in some way? Could this be somehow snap mapper related? We're just not, right? And especially since we're not convinced we're actually seeing this in our staging clusters. Our staging clusters do not have the same workloads as production, right? So that makes it harder to tease apart.
Are the so you only see it in production, so you can't like easily get a controlled set of tests.
That's the problem. Yeah, exactly. So I'll put it as we're not convinced we see it in staging. The reason why we're not convinced is unfortunately we don't have the Prometheus history to be able to run the same level of analysis. We only realized this was a issue once we started seeing it in prod.
Okay.
We have one staging cluster where we do have the history, and it's actually really weird because it looks like it actually has the amplification for like 3 days, and then it drops back down to normal again. But we have not seen that in prod. And where it dropped off in staging is when we did the conversion to column sharding in RocksDB. And so we're like, oh, that's weird. Maybe we should just do that. So we've done that for one or two, I think, full clusters in production, and it did not make a difference there. So fluke, we don't know, but it's like our single staging data point. I take, and almost any data from staging clusters, I take with a grain of salt. So I wouldn't put too much weight on what we saw there.
Okay.
But yeah, exactly what you say. We don't have any sort of isolated case where we know we can reproduce this, other than we just know it's happening for all of our production clusters on RBD. When I do the same analysis of disk writes per client write for our RGW implementations, I don't see any difference between Pacific and Nautilus, but we're not nearly as advanced there yet in how many clusters we've upgraded. So I still need to see some across that boundary.
Okay. But maybe that would indicate like if you consistently don't see it with RGW, maybe that could indicate something regarding overwrites.
Okay. Yeah, okay, that's a good point. I hadn't thought of overwrites yet. We were trying to brainstorm on like what are all the RBD specific things, and so like Alex, his first thought was, okay, well let me just go and disable all of the RBD features for volume staging and see if it makes a difference. But again, it's like, are we actually seeing this in staging? We don't know. So
Yeah. Oh,
yeah. So anyways, that's where that's at. I don't feel like we quite have enough data here to like write a ticket that's not just going to immediately get turned into need more info. So that's why we haven't
yeah.
written a ticket for it
Yeah,
yet.
yeah.
But anyways, that's where we're at on that one. I thought I would at least like brain dump that in case it triggers a memory for anyone. Like, oh, we changed this in Octopus or something like that.
I mean, like the things that come to mind for me are like column family sharding. Igor, I think the 4K min Alex stuff that you were working on, there was a lot that changed there, if I remember right, wasn't there?
Yeah, that's the question I wanted to raise. I'm not sure if it happened in Pacific. It seems it happened in Quincy only, but we might want to double check that. So yeah, if 4K allocation units are present in Pacific, this would definitely be the case since we had a bunch of reworks and deferred rights and things like that. So this might be the case then.
So I just wanted to double check my understanding with deferred rights. I don't think deferred rights don't apply unless you have separate wall and data, or do they actually happen even if you have a single device housing everything?
If I remember correctly, they occur anyway.
For some
This-
cases, deferred rights do happen anyway.
Okay. All right. That's interesting because my thought immediately went to deferred rights because I know there were changes around that in, I think, Pacific timeframe. But at first I thought it was only if you had like hybrid installs, and so I just kind of discarded that idea.
and the question is, what are your main devices? Are they spinning drives or SSD for this?
This is all SSD, mixture of SATA in our older stuff and NVMe in our newer stuff. But we see the same amplification in both cases.
We shouldn't be using the deferred write path then, right, guys?
Well, at least it's definitely less aggressive. But I don't remember exactly if we use deferred rights.
If both drives are SSD, then the defaults we use for deferred writes basically delete any non-necessary deferred writes actions. It means that if we overwrite a partial allocation unit, then we do deferred write, but that's only it. If device is spinner, then we also use deferred writes for performance, and in that case we will do extra. That's the idea.
Yeah, so deferred writes are still present for SSD main devices, but they are less aggressive, essentially.
So what about the case if they're on flash with only a single partition and they're doing overwrites to RBD? What would be the cases in which we'd be doing deferred writes?
The case would be when we have write size that is not completely matching allocation unit. Then we do read a part and put it through a deferred write, so there would never be a moment in time that we could create a corrupted data. That's when we use deferred write. But that brings me to a question, Joshua. If you observe some performance degradation due to additional writes, or you just notice that there is more IOs to the device?
So we definitely noticed a degradation in our older clusters at first. We've since made some tweaks to the disk configuration, our hardware configuration to compensate, but we definitely saw a latency increase there. After we've compensated for that, honestly, the performance hasn't been as the difference is minor, and actually the only place I generally see the performance difference is in the P50, so the median write latency. The median write latency tends to go up with Pacific. We usually see improvements everywhere else. Average is usually better, P99 is usually better, but the P50 does go up ever so slightly, like 20% or something like that, but so small that like I don't really care if it goes from 1 to 1.2 milliseconds. This is part of the reason why we haven't spent like as much time on it as we were before, because once we mitigated the older cluster problem, it's like, are we really that worried? It does become maybe a slight concern for wear leveling. Like, is it going to increase the wear on our TLC devices? We also have our two oldest clusters still yet to upgrade, and we've been holding off on those because those ones do have higher latency than everything else. So we're a little bit concerned that maybe something will happen there. But yeah, like we aren't seeing, now that we've mitigated the older cluster issue mostly, we aren't actually seeing a major end effect from this. It at this point, it remains mostly a curiosity and then a wear concern, especially if we do see it in the RGW side, because we're running spinners on RGW side without separated wall. So if we're going to see more IOPS against our spinners, we're concerned about that. And we are also running QLC, so we're also concerned about the wear there, right? But
Yeah.
like I said, we don't know yet whether it actually affects RGW.
And remind me from the previous conversations we've had, do you see an increase in the amount of data being written to this, or was it only an increase?
I'm fairly convinced that we don't, but the
Okay.
data was kind of mixed.
Okay.
I've gone back and forth on that a few times because every time I look at the data, it's like sometimes I decide yes, sometimes I decide no. If it is, it's not like a massive difference.
Okay.
It's pretty small.
Okay. So that could maybe indicate that something's getting broken up, right? Like for some reason we're breaking across a boundary or something where we didn't before.
Yeah. I can probably actually very quickly. Oh, I'll have to bring up a proper graph here. We recompute that now on one of the ones where we have like a more solid read on the problem.
Just a side note, I've just checked and 4K Minolog size came in Pacific.
Yeah, I thought it did.
So when you're referring to that, is the concern that there was or the thought that there was a set of changes to support the 4K min Alex size that might be in play here?
Yeah,
Okay.
something like that.
Okay. So there.
We discussed that PR or those PRs, I think, quite a bit several years ago in this meeting, and there were definitely performance effects early on. And Igor, I think you did quite a bit of work to mitigate a lot of that.
Yeah, I recall at least one issue with deferred writes, which duplicated the writes actually happening to disk, or something like that.
Okay, so per your question, Mark. So I've got a very clear example now, and no, like it is actually a significant increase in the amount of bytes written to disk.
Okay,
So
that's the concerning part.
Yeah. So what I'm seeing here is I'm just looking to see if I can share this. There's some stuff I don't want to share in this tab. Okay. What I'm seeing is, so that earlier calculation I was talking about where I'm calculating how many disk writes are happening per client write. Across the upgrade threshold, we went from an average of 9.5 disk writes. Remember, this is 3x replicated, so divide by 3 to get the per disk. 9.5 disk writes per client write, and it jumped to an average of about 12.1. And then over that same transition, we were averaging, I think this is saying 25 gigabytes per second written to disk across the cluster. And it jumped from the 25 to 38.
Oh, wow. Oh.
So that's huge, actually. I had actually not done that count that recently. That's pretty big.
That's really big. Okay, so yeah, definitely for where we should
Yeah.
we should track this down.
Would you say it again? What was the difference?
I'm actually just going to write into the Etherpad now, so we actually have the numbers written somewhere. Just give me a sec. So disk writes per client write. What did I even say here? Shoot. At 9.5 to 12.1.
Regarding deferred writes, happened much more frequently after 4K log size. This was resolved in Pacific.6 minor release. So just in case, are you what are the Pacific minor releases in your production clusters?
I'm sorry, I missed the question.
So I found the ticket which fixes unexpected deferred writes for legacy clusters in Pacific, and this happened for .6 Pacific release. So what's
Okay, yeah, we're running .9.
Okay.
And that was specific to spinners, right?
Yeah, and apparently
I'm trying to think if there's any way, Igor, we could verify whether or not it was those changes to support 4K malloc on spinners that might have caused this. Like if there's any way on there, because they're running NVMe drives, if there's any way we can.
Well, first of all, we can enforce HDD settings for NVMe drives, and hence it should, once applied, it should work similarly to spinning drives in terms of deferred writes and all other stuff.
But we want to
simulate. We can simulate spinners with NVMe drives.
But they're not on spinners. They're on right. You're on flash, right?
Well, yeah. So yeah. So it's.
But what I'm wondering is if it was possible that any of the changes that were made at that time could have impacted the deferred write path on flash drives.
It definitely could.
Are there logs that we can turn on temporarily that would highlight that issue at the OSD level?
Well, one more question about the staging clusters.
Yeah.
Were they deployed before Pacific as well, like production ones?
Yeah. So the example I just gave was from a production cluster. That production cluster would have been, let me check its history quickly here. I was going to say it was deployed on Nautilus, but I should make sure that it wasn't deployed on Luminous.
But again,
it was deployed on Luminous.
But on the other hand, we didn't change the allocation unit for flash drives.
No, we left that alone. But I was wondering if any of the changes that you made could have possibly impacted the behavior.
Well, I need to run through these changes once again to answer this question.
I mean, the other big thing was column family sharding, right? That was the big case that happened back then. Oh, Corey, you want to talk about what you found?
I was just recalling that one that Igor and Adam had both worked on where there was a bug in Pacific that still is there since we haven't had a release yet, but where older clusters that still had the 64K min allocation size that have been upgraded to Pacific aren't
Yeah,
deferring any writes based upon the small size, but I don't know if that makes sense as part of the problem.
that's the parent ticket for the tracker I said above. So this is for main, and that one is for Pacific backward. And again, it's happening for spinning drives only.
I'm pretty sure in Luminous we had a 4K min alloc size for SSDs, right? Like, you verified that, right?
For us in our configuration, we overrode that, and we've deployed 4K min alloc in our RBD clusters for years, even in
Okay,
Luminous and
good,
beyond.
good. Yeah, I was pretty sure in Luminous we'd had a 4K min alloc size for SSDs, but at one point earlier on it was 16K.
Yeah, we've always set 4K there.
Okay.
Oh, actually, let me double check that. It's funny because I work the object side so much, I just go to those settings.
I guess one more thing could have happened if you use one device or two devices for separate block data and RocksDB data.
Yeah, we use one device everywhere across all of our infrastructure. And I do confirm we do override 4K min alloc size for all of our block clusters.
Are you able to distinguish writes that came from block data writes and writes that go to RocksDB write ahead log? Is it possible?
When I look at the block trace, I'm pretty sure I can figure out which is which just based off of write patterns, but there's no way I don't think there's any way for me to do that at the stat level. Yeah, so we don't have like a histogram of write sizes or anything like that. I'm just trying to think of a way I could actually separate that at Prometheus level. I don't think I've got a way to do that.
But to make sure, when you refer that there is an increase of write access to the device, you are talking about the sum of block data writes and any metadata size. Okay.
Yeah, it's all the writes in aggregate to that device, since database, wall, block is all there.
Well, back to deferred writes, you might want to check BlueStack performance counters to get an estimate on whether they're happening and what's the amount of them. The best way would be to reset the counter, leave it running for a few minutes, and then collect again. So in all-flash setup, I believe they should be quite minor. So if you have large numbers there, then we need to troubleshoot further.
So I very quickly checked one OSD on this cluster, and it's logged 1 billion deferred writes in 4 weeks. That's per reset to reset those counters, right?
Sorry?
For the
Yeah,
reset? Yeah. Okay.
I think so. I believe that's what it is.
Well, it would be great if you share this dump and
Maybe,
maybe some short
yeah,
times
maybe it
one.
would be a good idea to fill out the ticket.
Yeah. I'm starting to think of that now too. Yeah.
Yeah.
Okay, so I reset the counters in the last like 5 seconds. There were 3,000 deferred writes, so like 600 per second roughly. It was very rough.
And
Timing.
what's about the amount of regular writes? Well, anyway, it's better to parse it offline. So please share it in the ticket.
Yeah, where's the count of regular writes?
But one thing for sure, deferred writes will amplify write count to the device.
Okay.
Maybe not write count, but the amount of bytes written to disk.
Yeah. Okay. Yeah. So very briefly, so I looked at this the done counter. Sorry, I'm trying to find one that would be like, what is the write count here? If I'm reading this correctly, it looks like the majority of the writes that were done were deferred.
Hmm.
Blue Store write small was 3324, and Blue Store write deferred was 3271. Blue Store write big was 782.
And what about amount of write big or something like that?
Yeah, write big was 782.
So you have much more small writes than big ones, right?
Yeah, small writes were 3300 versus the 800. So like 4 to 1.
Hmm.
Well, I believe this shouldn't happen for key allocation unit, since RBD does the padding itself,
Hmm.
and hence it should issue 4K aligned writes, which are not small. They're not treated as small for 4K allocation unit. So perhaps the root cause is buried somewhere here.
Sorry, where does RBD enforce that? Because I'm pretty sure we're exposing, like, very sure like the actual client in the VM is seeing 512 byte. So is there a read modify write that's supposed to happen somewhere in the stack?
Well,
Well, if your
oh,
clients do write in multitudes of 512, then yes, deferred writes are expected.
Hmm.
Yes, that could be. We just don't really test that configuration, I guess.
Maybe this helps us narrow down a test between Pacific and Nautilus. Maybe we
Mhm.
should be testing very, very small ones that enforce deferred writes and see if there's a difference.
I'm thinking the
Is that
same thing because our primary workload in staging is actually 4K aligned. Yeah.
okay.
So I'm starting to
Okay.
think, I'm starting to wonder, like,
Yeah.
is that why we don't see it?
Yeah. Yeah, it's kind of a hole in our testing. We don't tend to do a lot of like sub 4K like aligned or unaligned like testing. We
And
should.
and I have no idea why we expose 512 byte to our customers. The 4K, that's all before I started working. I came across
Okay.
that a couple of years ago. I'm like, oh, that's curious, but I haven't given it much thought. So
Yeah. Huh. Interesting.
um, I will file a ticket. I've noted the 512 byte thing because I might play with that in staging a little bit just to see what I can find there. I know I've taken up a bunch of your time already, so I don't know if we want to defer the T100 conversation till another
Yeah,
time.
we're over the limit today. Let's do it next week. Does that sound good?
Yeah, sounds good. Okay.
Cool.
Thanks all. This was really helpful. Hopefully we are driving towards a resolution.
Yeah. I don't like that 25 gigabytes per second to 38 gigabytes per second.
Yeah, I mean, to be fair, this is a very large cluster. So like what this translates to on a per disk basis, I'm not worried. But
No, it's more about the ratio, right? Like,
yeah. Oh, it's
like
true. It's pretty.
yeah.
Yeah.
All right. Well, anything else from anyone before we wrap up today? Thanks for sticking around, everyone. I know we went a little over. All right. Well, let's wrap it up and see everyone next week then.
All right.
Thank you,
so
guys.
much.
See you next week.
Thank you.
Bye bye.
Bye.
Thanks, Josh. Bye.